Hello everyone. Today I will explain my homework for exercise 3.2. Write a C hash to control C++ language by control ultrasonic sensor. Next, I will introduce the project objectives, hardware, code, and demonstration effects one by one. This project has four core goals. First, achieve two-way serial communication between the C hash host computer and Arduino running C++ program. Second, use Arduino to control the HCSR 004 sensor for distance measurement. Third, set the measured data to the C hash interface for real-time display. Fourth, realize LED linkage control based on distance to test if cross language control work. This is the hardware list. We need these hardware parts for the project. The crew control unit is Arduino Uno R3 board. Runs C++ programs. The main port for distance detection is HCSR 004 ultrasonic sensor. We also need one LED light for linkage demonstration and include a breadboard, some Jupyter wires, and a computer to run the C hash program. Now I will explain the connection details. First, connect the ultrasonic sensor to Arduino VCC to 5 volt, ground to ground, turg to pin 11, echo to pin 12, then connect the LED light, long pin to pin 13, short pin to ground. Finally, use the USB cable to connect Arduino and the computer. This cable provides power and enables serial communication. Arduino code. This is the setup function code of Arduino. First, we define 3-pin constricted for turg, echo, and LED, which match the hardware connections. Then we initialize several communication with a baud rate of 9600. This is the communication speed agreed with the C hash program. So they must be the same. Finally, we use the pin mode function set each pin mode. Turg and LED are output mode. Echo is input mode. Loop function. The loop function is Arduino min loop and runs repeatedly. The first part is the distance measurement logical. First, set a 10 microsecond turg pulse to the turg pin. Then use the puzzle function to measure the high-level direction of the echo pin. Calculate the distance with the formula size so the wave travel back and forth. Divide the time by 2. Then divide by 29.1 to get centimeters. The second part is linkage control. If the distance is less than 10 centimeters and varied, the LED turns on. Otherwise, it's turn off. At the same time, set the distance date to the serial port with several bytes for C hash to read. This runs every 500 milliseconds. This is C hash host computer. This page introduces the CH host computer interface controls and internalize code. The interface has a several port control for communication, a combo box to select the several port, two button to connect and disconnect, a text box to show distance, and a terminal to refresh the interface regularly. In the internalization code, we use several get port names to get all available several ports on the computer and fill them into the COM box automatically. We also set several port permits. The baud rate is 9600, same as Arduino, to ensure normal communication. Several port communication. These two button, this several port built in CH mode that automatically scores for correctly available several port numbers on the computer. This is the port connect several port button and the disconnect several port button. These two buttons realize several port connection and disconnection. In the connect button code, first check if the several port is closed. Then select the several port name from the command box and use the open mouse to open it. After success, start the terminal to refresh the interface every 500 milliseconds. Disable the connect button and enable the disconnect button to avoid repeat connection. The disconnect button stops the timer, closes the several port, restores the button stats, and clears the display box. We use try chat catch errors and show error message. This part code for date reception and UI update. The date received event targets automatically when date arrives at the several port. We use read2 to read date from Arduino, remove space, and light bricks, and stores it in the global variable since date received is a background sort. It can't operate the UI directly, so we use the timers tick event to update the text box. Show the distance date with the unit centimeter to make the result clear. This is conclusion. Finally, the cross knowledge point. First, the key to cross knowledge language communication is the UART several protocol. The baud rate and date format must be the same. Second, HCSR004 works by converting the duration between trigger pulse and equal pulse into distance. Third, we must event-driven programming such as CH date received and timer tick event and Arduino's loop function. Fourth, the hardware connections must match the pin numbers in the code exactly. This is the function for the function to work. Now I will explain the domain effects. First, after successful serial port connect, the text box on the C-hash interface shows the measured distance in centimeter in the real time with stable date update. Second, when the distance detected by the sensor is less than 10 centimeter, the LED on Arduino turns on automatically when the distance is 10 centimeter or more. The LED turns off. This realizes linkage control based on distance. Finally, after disconnection, the serial port, the interface stops update. The display box is cleared, and you can select the serial port to connect again. The whole system runs stable and achieve our preset project goals. Let's look at the video. That's all my homework explained. Thanks for your listening. Goodbye.